The story of the Big Bang Theory's origin is a fascinating journey through 20th century science. It weaves together the work of visionary thinkers, daring mathematical predictions, and revolutionary observations that transformed our understanding of the universe. When we ask, who proposed the Big Bang Theory? The answer is more nuanced than a single name. It's a tapestry of curiosity, debate, skepticism, and eventual acceptance. Let's embark on a journey through space and time to uncover the characters, the moments, and the evidence that led to the establishment of the Big Bang Theory. As the 20th century dawned, astronomers had only just begun to understand the true nature of the universe beyond our own Milky Way. For centuries, the universe was believed to be static and eternal, unchanging on the largest scales. This belief was so deeply rooted that even Albert Einstein, who revolutionized physics with his general theory of relativity in 1915, initially resisted the possibility of a dynamic universe. When his equations suggested that the universe should either be expanding or contracting, he modified them by introducing a cosmological constant to keep the cosmos static, a step he would later call his greatest blunder. Yet, even as Einstein was wrestling with the mathematics, a Belgian priest, physicist, and astronomer named Georges Lemaître began to explore the implications of Einstein's work. In 1927, Lemaître published a daring and transformative idea. If the universe is expanding, as Einstein's equations seemed to suggest, then it must have been smaller in the past. Lemaître proposed that the universe originated from an incredibly dense and hot state, what he called the primeval atom, or the cosmic egg. He envisioned the cosmos suddenly expanding from a single point, setting in motion all the matter and energy we observe today. Lemaître's insight was profound, but science thrives on evidence as much as theory. Around the same time, an American astronomer, Edwin Hubble, was turning telescopes toward the stars and galaxies beyond the Milky Way. In 1929, Hubble made a discovery that would shake the foundations of astronomy. Galaxies were not only far away, they were also moving away from us. Even more, the farther a galaxy was, the faster it was receding. This observation, the red shift of distant galaxies, provided direct evidence for an expanding universe. Though Hubble did not interpret his findings as proof of Lemaître's idea, his observations lent critical support to the concept of an origin in time. With Hubble's discovery, Lemaître's proposal, once considered speculative, now had a compelling observational anchor. Lemaître corresponded with Einstein about his theory, and gradually, others began to take notice. However, not everyone was convinced. There was still debate as to whether the universe had a definite beginning or if it had always existed in some steady state. The name Big Bang itself comes from a skeptic, British astronomer Fred Hoyle. Hoyle was a passionate proponent of the rival steady-state theory, which posited that new matter was continuously created as the universe expanded. In a 1949 radio broadcast, Hoyle referred to Lemaître's model, somewhat dismissively, as the Big Bang. The catchy term stuck and eventually became the widely accepted name for the theory, though it originally was meant as a pejorative. Despite its name, the Big Bang was not an explosion in space, but rather an expansion of space itself, carrying energy and matter along with it. The theory posited that, at its earliest moments, the universe was unimaginably hot and dense. As it expanded, it cooled, leading to the formation of atoms, stars, galaxies, and eventually, everything we see today. The Big Bang Theory received a monumental boost in 1965. By then, the theoretical groundwork was rich. George Gamow, Ralph Alpher, and Robert Herman had predicted that if the universe began in a hot, dense state, it should have left behind a faint afterglow, cosmic microwave background radiation. That year, Arno, Penzias, and Robert Wilson, working at Bell Labs in New Jersey, stumbled upon a persistent background hiss while calibrating a radio antenna. They could not explain the source of this noise, which appeared to come from every direction in the sky. Unbeknownst to them, they had discovered the very radiation predicted by Big Bang theorists. diffused heat left over from the universe's fiery birth. Penzias and Wilson's discovery confirmed one of the central predictions of the Big Bang theory, turning what was still a subject of debate into the dominant explanation of cosmic origins. The steady-state theory faded as more evidence mounted. Not only the microwave background, but also the relative abundance of the lightest elements, hydrogen, helium, and traces of lithium, all matched predictions made by Big Bang nucleosynthesis. Over time, the details were refined, widgets and addenda attached as new data came to light. Sophisticated experiments mapped the cosmic microwave background with exquisite precision. New telescopes peered farther into the universe's history. The accelerating expansion of the universe, discovered in the late 90s, added further chapters, pointing to a mysterious force dubbed dark energy. So, to return to our question, who proposed the Big Bang theory? The answer begins with Georges Lemaître, the visionary who dared to suggest that the universe had a definite origin, a beginning in time. Lemaître's work was both bold and mathematically sound, rooted in Einstein's relativity and energized by the courage to question prevailing wisdom. But science builds on the shoulders of giants, and the Big Bang theory is no exception. Edwin Hubble's careful observations provided the crucial evidence that the universe is expanding. George Gamow, Ralph Alpher, and Robert Herman predicted the afterglow of creation, while Arno Penzias and Robert Wilson supplied its most convincing confirmation. A collaboration across time and disciplines, the evolution of the Big Bang theory is a testament to the power of curiosity, critical thinking, and the willingness to follow the evidence wherever it leads. Lemaître himself was a man of deep faith and relentless inquiry. He saw no conflict between science and religion, famously remarking that the Big Bang, the moment of cosmic creation, did not reveal the workings of a divine hand, but rather marked the realm where science ended and metaphysics began. He was content to let the facts speak for themselves, fittingly modest about his revolutionary proposal. The Big Bang theory not only tells us the universe has a history, it gives us a way to read that history. Each photon of light that reaches telescopes today has traveled billions of years, carrying with it the story of creation's unfolding. In the cosmic background, radiation lies the echo of the universe's first moments, still whispering across the void. Every element heavier than hydrogen, every atom in our bodies, was forged in the furnaces of ancient stars, themselves the children of the Big Bang. Today, the Big Bang theory forms the cornerstone of modern cosmology. It explains not only the expansion of space and the origins of matter, but also frames our search for understanding dark matter, dark energy, inflation, and the ultimate fate of the cosmos. It connects the largest structures, galaxies and clusters of galaxies, to the most minute particles and the forces that govern their interactions. In classrooms, lecture halls, and late-night discussions under the stars, the story of the Big Bang captures the imagination as few scientific stories can. It reminds us that the universe is not static or eternal, but a dynamic arena of astonishing events, governed by laws we can, to some extent, comprehend. It shows that human curiosity, our relentless desire to understand, can reach back in time to the very inception of all that exists. Thus, when we seek the answer to who proposed the Big Bang theory, we find not a single hero, but a constellation of minds. But it is Georges Lemaître, Belgian cosmologist and priest, often rightly recognized as the father of the idea. His primeval atom, his cosmic egg, has taken flight, inspiring scientists and laypeople alike to wonder, what came before the bang? What will happen next? And how is it that we, made of stardust, can contemplate our own beginnings? The story continues, as new observations, theories, and experiments push the boundaries of our understanding. Perhaps future generations will uncover new layers, fresh evidence, and even more profound mysteries. Yet, the spirit of Lemaître, Hubble, Gamow, and all the rest remains, an enduring drive to ask, to seek, and to discover. In the grand tapestry of cosmic exploration, the Big Bang theory stands as both an answer and a question, a reminder that the universe was born in a moment of spectacular transformation, and that humanity's greatest adventure is not only to comprehend the cosmos, but to stand in awe of its wonder.